Good morning, good afternoon, everyone. We're about to start in 1 to 2 minutes. People are still trickling in.
Yes, hi everyone. Good morning and good evening, depending on where you're calling in from. Actually, I would love to know where are you guys calling in from? You can drop it in the chat. I'm calling in from San Francisco. Ooh, France, nice. Jörg, where are you calling in from?
I'm also calling in from San Francisco. Oh, we're from in Sweden. I used to live in Linköping.
Hello to everyone who's joining. We're just going to give it a couple minutes before we get started to have more folks trickle in. And I guess while we wait, feel free to drop in the chat what you are hoping to learn at the event, or what you're most interested in. Actually, I have another question for everyone. What is your favorite AI buzzword? You can go first.
Uh, pr- I hope it's transitioning out of the buzzwords category slowly, but probably MCP.
MCP.
Yeah, model context protocol. I think there we are on a trajectory, actually moving that out of the buzzword world and moving it into a production. Well, we'll talk about it a bit during the webinar. Um, but yeah.
Yeah, is MCP just APIs or is it tool calling?
Um, uh, I think leaving that discussion aside, I think the hard part for it is how can I leverage it in kind of like a production setup, right? Even like latest release as of a few weeks ago, I think it got a lot better in terms of authentication authorization, but I think we still have a few steps to go until we'll have uh, live production grade working with MCP out there. I just have to smile about the vibe and vibe coding because we were just talking about vibe webinaring just before. Um, so yeah, I can second the vibe and vibe coding.
And agentification.
Yes.
Yeah, that's
And
one. I think I know what it means. I I think so. Or yeah,
I,
AI. I'm like, isn't AI machine learning, right? Aren't isn't that a subset of machine learning, or is AI
yeah.
different?
You can argue what is a subcategory of what, but yeah, I mean, maybe just for all of us, I felt it was the same when I had a similar talk, like when deep learning, like 2018, 2019, where I felt everyone was jumping on deep learning. I believe it's know the tools you have, right? I think they're all great tools, but you should be very mindful what problems you're applying them to. So apply the right tool for the right problem. And I think that's going to get you to business value in the end.
Totally.
Yeah.
So yeah, we are 4 minutes in. I think we can get started. Uh, Jorg, I will make you the host and then you can
Thank you.
get started.
All right. Thank you very much. I hope everyone can see my screen. Yeah. Good morning, good afternoon. Thanks for joining. This is actually a webinar or a talk on like two of my favorite topics, data infrastructure and AI ML, and how to combine them to actually create business value, or how we call it here, going from like prototype code to actually real production ready business value creating installations. I mean, if you look around in, if I remember like the early days of LLMs, like end of 2022, early 2023, I remember playing with like the first ChatGPT versions out there, and it really felt impressive what it could do. But then looking back, I feel the real value creation, it started once we started connecting LLMs or ML in general with our own custom data sets. So basically data sets which are either personal to us or which are private to our enterprise. But this is basically when we started creating value out of it. And this is a Forbes article from like early 2023. And I still believe this data gap, this is still key to AI, to Gen AI, or whatever flavor of ML, as Shap put it earlier, we are talking about. I mean, if we just look a little bit at the stack, right? On the top, we got ML, we got Gen AI, we got LLMs, and nowadays we got a lot of agents, multi-agent systems out there. Until like end of last year, probably the big connector between the upper layer and the lower layer, the enterprise data was RAG, Retrieval Augmentation Generation. We also talked about it in a webinar earlier. But that was basically kind of the connection, right? We created embeddings and then we exposed and leveraged those embeddings in our LLMs, in our chatbots, or even our agents. And I still believe it's a very valuable technique. But as of early 2025, probably the big trend and also, let's call it hype, was probably around MCP, the Model Context Protocol, which is all about making tools and resources available to agents, to LLMs. So basically, tool calling, and also giving access to our enterprise data with context. So I think it's a very powerful technique. I personally hope that MCP as a protocol, it still has a few steps to evolve, but otherwise, I think it's a very powerful connection between those two layers in that stack. If you look a little bit at the velocity of innovation across a stack, in the upper layer, ML, Gen AI, this is changing very rapidly. There's a new framework, there's a new model version, or something new basically every day. On the other hand, kind of the layer down there, our enterprise data, it's typically changing very slowly. First of all, just the data infrastructure itself, but then also kind of like how can I get access to data? This is like in the order probably of months, if not even longer. Whereas the upper layer, there's, as mentioned, there's a new ML framework probably every day, or at least every week, we could start playing with. The connecting layer is somehow in between. So I would say it's kind of like a medium rate of innovation and change. As mentioned, until end of last year, kind of like RAG was probably the focal point. Now we got another connector tool in our toolbox, which is MCP. And so we're kind of like in that velocity of change, probably measured in months or like six to 7 months of innovation change. Seeing MCP, probably we have a new version right now about every 1.5 to 2 months. So that's a bit faster, but the overall rate is kind of like in between the really fast moving ML world and the slow moving data world. Sounds great. So why can't we just use that and build production applications? It is still a pretty bumpy road from going from like prototype code to production. So what we often hear is that people, they have a really great project. A large enterprises, they either have an internal team or they have like some consultants or external experts coming in. They grab a pre-cleaned, really nice CSV file or other data set stored locally somewhere, and then they start building that into a really cool Jupyter notebook. They present it to upper management. Everyone is excited. But once we try to turn that into production code, we are basically failing to convert that from this basic notebook entity into a production setup. If we manage to do that, we still then have the problem of data access. As mentioned earlier, that data layer is fairly slow, and the upper layer, kind of like what we have and what we want to connect it to, is super fast. So if we want to connect this new prototype we have built to a new data source, to a potentially different domain of data, this is usually takes us is a slowdown once we want to move that over. So next problem, we might also even solve that. Then we are often hitting like the next problem, and this is actually that too much data is also not great. So here there's a paper, they call it context rot, which basically means if we are exposing too much data or too much context to the LLMs, to ML in general, or to our agents, we will actually also have not the performance we are looking for because basically we are overwhelming the LLMs. And as a side effect, we are often also overwhelming our cost for it because the more context we give, the more tokens we're going to consume. And therefore, the higher our bill usually ends up being. So, next kind of challenge. If we overcome this, then we are still facing the safety aspects of it. So probably many of you saw like last week there was this threat going on that kind of an AI coding tool wiped out a bunch of production databases and actually tried to even cover up its tracks. If we go back a little further, there's also the issue of chatbots accessing data they shouldn't have and therefore exposing high-level management emails. That was last year, I think, over at Microsoft. So we still are facing this safety problem. How can we use all those technologies safety? Because as we said earlier, we want to connect it to the oil of our company, which is our data. If I had to categorize these challenges, I would say this actually goes from standardization. How can we have standardized access and standardized interfaces to speed? How can we live up to that speed of innovation in the upper layer? How can we replicate that to the data access layer? Then specificity of context. How can we get enough information, but not too much information to our agents, to our chatbots? And then last but not least, safety. How can we make access safe and not yield any PII or any sensitive information which we shouldn't to the outside? We're also going to use this a little bit to structure our talks. We'll go through those individual challenges step by step and then see how we can deal with them. Why do I care about this? As mentioned in the beginning, my background is a lot of data and machine learning infrastructure building, systems architecture, but I would say really my passion is about combining that with ML. Was already like back when like deep learning was a hype. We built a lot of architecture for various companies. Then also in my job before, worked a lot with like graph-powered machine learning. So I'm really happy that in this webinar I can actually combine both those passions into like one talk. On a higher level, why do we as a company care about that? Nextdata, we are all focused about how can we create value in a scalable fashion from data? How can we share data products? How can we build data products? How can we govern data products? So if we would go through kind of what our daily life is over here at Nextdata, we want to enable creators of data products to build and share their data products, basically data access to data sets, including metadata, really fast. So typically in typical business environments we deal with, this is a matter of weeks, if not even longer. And we really want to cut that down to like below minutes. We also want to enable users to be able to discover and trust the data. So this is not just a pure catalog where I can find data, but I really want to have also the policies. I want to see what this data set actually guarantees me, and I want to see, does it actually live up to the promises it is making? So kind of the trust and automated data access. Platform engineers who are nowadays often facing this, oh, I have to actually support the end use cases. We want to enable them to be able to focus on building and onboarding the core data infrastructure, the new services, and really focus on running them, onboard a new service in under an hour. And I think this really also helps the focus on what they are great at, maintaining and operating data services and platform. Last but not least, there are also the managers on top. They want to be able to observe and still have certain governance rules. As mentioned earlier, we want to make sure we are not leaking PII data. And while we want to enable all creators across the board, we still want to make sure that there's some kind of central control and central rules which everyone has to follow as if they want to publish their own data products. Okay, as mentioned, we wanted to kind of like follow through the individual challenges and let us see how Nextdata slash data products, autonomous data products, can actually help us deal with those challenges. The first challenge we mentioned evolves around standardization. As mentioned in the intro, we often see people are building a prototype, and those prototypes often they go in, they have a really nicely cleaned up data set, which some data engineers worked on before. I load that into my Jupyter notebook. I'm building out my really cool model, and then I'm basically sharing that. I'm presenting it to upper management. Everyone gets excited, but then we are failing short in migrating it over into a production setup. The challenge we often see with that is the data access. So in those Jupyter notebooks, as I could start out with a CSV file. I could even start out with like a small, for example, DuckDB instance. But then when I'm moving to my production real data, which in the end also creates a business value, I'm often faced with other technologies such as Snowflake, such as Databricks, data lakes, or others. But basically, this is where it gets really hard. How can I move it from the small POC-like data source to a real production grade data system? And this is one of the core ideas for data products. Data products, they're kind of, if you want to think about them as the equivalent of what Docker or containers did for microservices, this is a similar abstraction for data. Imagine if I'm using a Docker container, I don't have to worry about whether it is Rust inside, whether it's Python inside, whether it's Java inside. I just do a Docker run. I get a well-defined interface to work with my container. And this is also true for observability and basically across the stack. And this enables us to build also like orchestrators such as Kubernetes. If you want autonomous data products, they're kind of the equivalent for data. So we have certain standard interfaces and APIs for example, sensing inputs. Has something changed upstream, and I might have to rerun my transform. It offers an abstraction over the compute and storage infrastructure. So I could, for example, very easily switch from a DuckDB implementation over to a Snowflake implementation, over to an ADLS implementation without disturbing and forcing massive changes from my downstream consumer because they're going against the standard API out there. Similarly, on the top, we also have standard APIs for discoverability, observability, and the self-governance part. And I think the biggest aspect of all of this is to think about data products not just as a static asset, but actually as a running service I can query. And this is also all of the data product is API first. So here's, for example, the API of a data product or the API documentation of a data product. Each data product I can interact with on an API basis. And what we're later going to see when we jump into the actual system is actually just the UI using this data product API, but I can build any system using those APIs directly as well. So API first. If we want to understand a little bit more how data product works in context, here's an example of a customer feedback data product. So that feedback data product is basically, it's going to take both structured and unstructured information, and it's going to make it consumable for different consumers. So if we start looking at the input side, we got two input data products. One is our point of sales customer feedback. Imagine you go in a store, you fill out some kind of like feedback form, and like once a day, once every week, they're going to scan that and ship it over to central headquarters. So very unstructured data we have to deal with. On the other hand, we might have Amazon product reviews, which is a very standardized format. This might be a SQL table where we have all our information in. And this is what we want to combine in our customer feedback data product here. The first thing we see here is that little check mark, integrity and quality verification. Before we start touching that data, before we start consuming this data and transforming it within our data product, the first thing we do is actually we check, does it comply to our quality standards? Does it include any information we, for example, shouldn't process on a certain platform? Is there some kind of user human identifiable information in there? So basically, we can do that before. The other aspect of this is it also allows us the sensors we have on this input side, they allow us to schedule and orchestrate how often we want to run this data product. A pattern I've often observed is we have a Spark job which is going to run every hour, for example, but in the end, there's only new data once a day, and maybe even the output only gets consumed once a week. So by having those sensors and then certain trigger policies, I can actually control how often do I want to run, how often do I want to update my output, and basically balancing kind of the up-to-dateness of data together with like cost aspects. I mean, it's great for Databricks if we run a large Spark job every hour, but for us as a business, it's actually great if we have control and we can save cost if needed or if it makes sense. Then within that data product, as mentioned, we have an abstraction for the underlying storage and compute. So from a data product perspective, there are those little connectors down here, which we call drivers. So we have drivers for different platforms from ADLS over Snowflake, over S3, over Databricks, and many more. And this is a standard interface we can leverage, and it allows us to, for example, also support new technologies, new storage and new compute technologies fairly quickly because we can just develop like a new driver for this. So this actually allows kind of the standardization we'll talk a bit about here to switch out underlying storage technologies. So for example, if for my POC I'm using DuckDB because this is good enough for the sample data, I can fairly easily switch that out by just a few lines of code change for example, a large-scale production Snowflake instance. Very similarly, if I need to migrate, for example, from one cloud to another, or if I'm migrating like from one region to another, it is a fairly easy change and it won't affect any other parts of the system. So in particular, like the upper layer here is the discoverability and also governance aspects. they are abstracted away from that. And also on the consumer side, I'm typically just minimally exposed to any of those changes. That's actually a good lead over. Let's talk about the output side and consumer side. Analogous to the input side, we also have so-called promises here. So we have computational validation of the output of our transform, the data we want to make available to downstream consumers. So before any downstream consumer can access and even see that there's an update, there are going to be certain checks running. This can be either platform supplied checks, or it can also be custom checks. We are integrating with also like a lot of data quality tools out there. So if you already have something, this is also again supported through the driver abstraction. But that actually ensures that data is being checked before any downstream system might be able to pick it up or might even sense that there's an update. Talking about different consumers, one of the other aspects for data products is what we call multimodal output. So multimodal output, you've probably seen that often that even though we are talking about the same semantic data, the same, in this case, for example, customer feedback data, different consumers require it in different formats. So for example, if we are building a RAG-based chatbot against our customer feedback data, having an embedding representation of that data is going to be the way to go. On the other hand, if we have some data scientists who want to dive into the data set, probably like a SQL-based output is going to be very helpful because then I can interact with that through a notebook, through any other system. On the other hand, if I want to build some model fine-tuning, if I want to train or fine-tune my LLMs, probably some kind of like file-based or document representation of that data set is going to be great as input to that. So these kind of like different modalities, the same different physical representations of the same semantic data are very helpful for different consumers. And again, this is something autonomous data products actually enable us to build via different output ports. One kind of specific output port we have down here is also MCP, or to generalize it a bit more, kind of like API-based output port. And this is what we again see as part of that standardization. I, as a data product developer, I can actually hint and embed in my semantic model what are the questions my data product is great at answering. I mean, I can always go the general route and just connect to the rack output and basically get everything. But to be more targeted and to be more specific, I can define MCP resources, which are then being made available to agent consumers out there. And as mentioned, we see that as part of the semantic model. And we'll see that in a bit more in a concrete example later on out there. Let's move over to the next challenge, and that would be speed. So if you look out there, I think kind of like the bridge, the gap we have to bridge right now is that if we're looking in this AI field, those agents are first of all running really fast. Just the iteration time they have, this is like below 1 second. Also, the other factor for speed is just how quickly I can develop them and might just want to test them out. And this is usually in conflict for how long it takes to make data available. So typically the time to make data available in traditional infrastructures is somewhere in the range of weeks to months. And usually, often, or at least often, it involves fairly complex governance processes. I have to talk to a central team who can have access, etc., and then apply that. So basically, making this available to agents is slower than it should be. This is in particular true if we're talking about what we call unmanaged data. Imagine APIs, imagine SharePoint services, or basically files which are not stored in traditional data infrastructure, such as ADLS, such as data lakes, etc., but are kind of like our operational systems. So, especially for those, we see a large gap making that safely accessible to agents or in general LLMs. This is where we see Nextdata or data mesh in general coming in as an abstraction layer. By relying on those data products, we have a standard interface. So we actually we turn that time down to less than hours, often just minutes, how we can make new data available. Because of the standardization we talked about earlier, those data products are offering standard interfaces, giving enough context what they're about to be quickly consumed by LLMs and agents. That just leaves us with a problem. How do we create? How do we construct our data products? Do we have to go in all hand code that? No, luckily, this is also where kind of AI can help us. We have a multi-agent system. You can imagine that kind of be a co-pilot supporting you in creating data products. And we've seen that taking down the time it takes to create a data product really to like just a few minutes for a new data product out there. So uh, basically coming down to like two layers, the kind of like time to make data available to agents, to LLMs. It gets tuned down, first of all, because we have a standard abstractions through the data products. And secondly, we can create those data products really quickly, thanks to Nextdata, thanks to also like GenAI co-pilots, multi-agent co-pilot system. Okay, that brings us to specificity. This paper introduced this nice term like context rot, but basically what it describes is how increasing input context, the more context I make available to a particular system, can actually decrease the performance. And here's another benchmark from LangChain, where they benchmarked a single agent performance for varying context size windows. So basically what you see on the X dimension here is like the more context we make available to the agent. And then on the Y dimension, we see like the basically task completion rate. So higher is better. And we can see the more context we make available to agents, the less our task pass rate percentage is going to be. So basically, performance is going to decrease if we give unspecific information to agents. And this is a really interesting blog post. I would recommend everyone who's interested then to read it. But basically, coming down to there's a performance drop if we make data or tools available which are not relevant to solving the task, because then the LLM has to choose the right tool, the right data, and the more there's available, the harder this selection task is going to be. There's some interesting follow-up work. Of course, the title here says single agent. How that can actually be generalized to multi-agent systems. I think my personal TLDR is if you have a multi-agent system where each agent can be very specific to one subpart, therefore having specific access to tools, to data specific to its task, you kind of end up with an easier infrastructure in managing the specific context being made available. How I would phrase that, I like this term domain-centric Gen AI, kind of from a domain-driven world. And this is all about making task-specific data and tools available to agents for increased performance and also reduced cost after all. So the first kind of pillar of that would be domain-driven data. So for example, what context we make available to RAG. And the more isn't always better. So the more specific data we can make accessible, so kind of like pre-filter up front, the better the output is going to be, rather than just giving access to an entire database instance to an entire, just connect my data lake via MCP to my LLM and hope it's going to select the best data. This is usually not going to help performance. The same is true for if we talk about MCP tools and resources. Too many tools are just going to overwhelm the system, as shown in the earlier blog post by LangChain, and are just going to overwhelm the models, the LLM reasoning. So the more specific tools we can offer, the better. And I also believe talking about multi-agent systems or different fine-tuned LLMs, this is also true if we're actually talking LLMs. There are already different base models which are very good at specific tasks. So, for example, if I want to do a coding task, I'm going to choose Gemini. Personally, if I want to complete a graphic task, I might choose another base LLM. Furthermore, we often have fine-tuned LLMs which are specific to a particular domain. For example, a marketing domain probably is going to use a different vocabulary than the finance domain, and is also going to be faced with different tasks than the finance domain. So having fine-tuned LLMs for different domains is also really going to help our performance and is also going to decrease the risk of hallucinations or simply wrong answers out there. So how can we tune that and how can we serve that through data products? Or how can data products help us with that? And this is kind of the agent cycle we are seeing with data products. And I think the first kind of step here is intent discovery. So I'm getting a prompt and I'm evaluating the intent from this prompt. What at this instance is available to the agent? What tools or resources? I use tools here just kind of as a shortcut for tools and resources, but the only kind of tool which is available at stage one would be discover other tools. So this is often called progressive tool discovery. So I'm just starting out with a very specific tool, but then I can discover other tools I need for a particular task, for a particular context. So that would be kind of the first thing. The second step for the agent then is to discover available data products and tools. So what do I have available out there? And for that, there's the Mesh API it can talk to, or basically a system data product being available, kind of giving an overview of what data is available in the cluster and what is the metadata being associated with that. So we can make actually a very good decision what tools we should make available to the agent for a particular task. And then, for example, the list of agent accessible tools might look as follow. We still have our discover tools for a specific context. And then we just discovered a new tool, and that would be customer feedback, kind of the shortcut, the namespace for our customer feedback data product, and then the particular function, the particular tool get customer feedback for a particular channel. And this is supported by the MCP protocol that basically we can make tools available step by step throughout the process, or we can also make tools unavailable throughout a session. So now we have made task-specific tools available, and the LLM slash the agent can now select the tools it wants to use to answer a particular question. It can then retrieve the data for this. And again, this is something where the standardization of data products is actually helping because, first of all, we have an access controlled MCP output port. So the same access permissions which apply to normal data products also apply to the LLM access and agent access. And if we would do, for example, rec on the embedding output, again, the same would be true for that kind of access. And then basically the LLM can do its work, can make LLM-based discussions and action, and we start over again. Evaluate intent, discover and reset accessible tools, select data retrieval decision, discovery, select data retrieval, and so on and so on. And basically, this is our new agent lifecycle based on data products. Okay, with that, let us move to kind of like our last part, and this is about safety. As said, like last week, there was kind of this big thread about AI coding tools just wiping production databases, fabricating users, and basically even like giving wrong answers to kind of like cover up its tracks. And we should always consider how much write access, generic write access, we want to give our AI tools without human validation. So I think this is one thread to that. But the other thread is how can we enforce this to be safe? So, for example, what we are also often seeing. There's a data product developers, they want to build data products. They actually want to make it available to LLMs, to agents. But then there is kind of that mean person out there, CISO or some kind of data safety person who is saying like, oh, we actually cannot use LLMs in general because we are afraid to expose PII. We can only use it in certain context. And then basically, usually what starts happening, each data product which gets deployed has to go through like a really long review cycle. And if you recall, we said like one of the challenges we want to solve here is actually for speed. We want to be able to make data available to agents, to new use cases as quickly as possible while being safe out here. And this is where the concept of policies is coming in. Recall, we have those promises on the output side. So promise, I can, for example, as a data product developer, I can write in my own promise, which is checking that I'm not exposing PII data. I can enforce a promise, which is I can, as a data product developer, enforce that I'm only using my own custom enterprise specific LLMs. So we've seen that with a number of customers and prospects who basically within their organization they have their own LLMs, but they are not allowed to use like a generic ChatGPT and generic Gemini being available. And so I can also ensure that as a data product developer. Still, as a CISO persona, how can I be certain that all my data product developers are going to follow those guidelines without having to go through lengthy reviews for each data product being put out there? And this is where policies are coming in. So basically, Nextdata OS supports a central contract repository where someone has specified, oh, this is a no PII promise out there. And then data product developers, they can actually leverage this promise in their own data product. Furthermore, we have a policy engine which actually ensures that for all those PII, that PII promise is applied to all data products, either in a particular domain or if you want to imagine also like across the entire mesh. So you can basically say like which areas it should apply to. And if it doesn't apply to your data product, it's not going to run, it's not going to be able to be deployed. I always see kind of the analogy in the Kubernetes space with like an admission controller, which is checking certain conditions. And if I'm not meeting those conditions as a data product developer, I cannot deploy my data product, or it's not going to run after all. So this is basically giving our CISO the safety that while he is enabling all data product developers to develop quickly, still the governance standards required for that particular domain, for that particular vertical are still being followed out there. All right, let us quickly jump over and see how this is looking in reality and practice. So here, this is our demo Nextdata cluster. It's focused around an e-commerce domain, and you can see those different blobs basically representing different domains. So here, the big one here is our retail domain, and retail has certain subdomains, as for example, sales, which we'll dive into in just a second. Already at this altitude, at this level, we can see certain dependencies. So if we, for example, see that the sales domain is consuming from the wholesale domain and it's consuming from store operations. If we zoom in a bit, we see that even more fine granular, and we start seeing our data products. So here, our hexagons, they are our data products, and the number in them is actually representing the number of semantic models being served by this data product. And we can also see the dependencies. So for example, if we here look at multi-channel sales, it is consuming from three other data products: store sales, wholesale sales, and online sales. Um, and it has another downstream consumer, which is sales value. With that, let's take a look at multi-channel sales, and in particular, how does it help us solve the challenges we've been talking about in this webinar? So the first thing we see is a data product is actually an integrated part of data, metadata, and promises, computational policies we are making. So the first thing we can see here is a quick description. So our multi-channel sales data product in this case is actually aggregating the trending and emerging products sold across like all channels. We have both transactional and channel-specific sales performance across all regions being available. So this is what we typically would call an aggregate data product because it's consuming from other data products and then is making that accessible. Next thing we can see here is the current state. It started, it's currently healthy, and it last updated, oh, just 5 seconds ago. So that was basically the last run, the last time we ran the transformation. Furthermore, we can see the owner or producer of this data product. So if I have any questions, requests, I know actually who to contact out there. Next thing, this is interesting because it relates to our standardization. We can see the underlying storage and compute technologies. So in this case, we're using ADLS, Snowflake, S3, and Pinecone. I always preface that with probably for realistic data product out there, as these are a lot of services, especially duplication between ADLS and S3. But I think it nicely helps us to understand the concept. We are abstracted away from the individual services, as we'll see in a second, and we can leverage them the same way. Great. Next thing we see is kind of our trust summary. So trust summary, it is an aggregated value of if I'm new to that, I just discovered that and I'm wondering, should I actually be using this data product? It gives me a good indication. So for example, I'm seeing it's being fairly accessed and leveraged by others as well. So it's a used data product. There isn't like just a single consumer out there. I'm seeing that all its promises are passing and also its input expectations are being met. So this kind of helps me to establish trust whether I might want to consider using this data product myself. Next thing we're seeing is other different models. And so, as mentioned earlier, there are three models being served by this data product: the channel sales velocity, the emerging products being identified, and the trending sales. So those are the three distinct semantic models being offered by the multi-channel sales data product and being made available to me on the output ports. If I have the right permissions and my data product supports it, I can also see what we call discovery data. And again, imagine I just discovered this data product. I'm considering using it. So I can get like a first glimpse of what is out there. And I, as a data product developer, I can actually specify and make sure that I'm not exposing, for example, PII in my discovery data because I can finally control what discovery data should be shown. Next, we can see the different inputs. So where is this data product consuming from? As mentioned, we are consuming from three other data products, and this is store sales, wholesale sales, and online sales. We can see that in this case, all the input expectations are passing. So we are getting good data from upstream. And if we scroll further down, we can also see our different expectations we are running. In this case, it is a mix of kind of like our own expectations we are defining. So I can define my own custom Python checks, but also I can leverage other tools for which we have drivers available. With that, let us move to the output side. So on the output side, we have three storage outputs available: ADLS, making it available in kind of a more document-like format, as mentioned, for example, for training purposes; Snowflake for our data scientists wanting to access relational representation of our data; and then Pinecone if we want to go down like a RAG agent LLM use case for consuming this data. Uh, Equivalent to the input side, we can see the promises being available here, and they really help me understand what can I rely on when I'm accessing this data. So for example, here we can also see that they passed, so I can build a trust in this data, and I can see what is all being checked. And this is being checked automatically, and for most of them, they will actually prevent, if they would be failing, I wouldn't see and I wouldn't be able to access kind of bad data. With that, let's quickly jump over to the implementation of that and look at actual code. So first thing we're seeing, data product, it's really a combination of documentation, source code, and promises we are making. So it's basically a bundle of all of that together. This is something we've seen often and anyone doing software engineering knows that, right? Once you start storing information at different parts in different systems, for example, if the README is stored in one system, the code is stored in another, it really starts to drift, and all of a sudden my documentation is not updated while I'm updating, for example, my models out there. The core part of a data product is the data product spec. So if we start looking at this, we got two ways of specifying a data product. The recommended one is our Python DSL, and that allows like a very simple way, very simple Python code to specify my entire data product. This is equivalent to what we've seen in the UI. So first thing we specify is our general information, our general description. We have a version, and we are referencing our infra profile. The infra profile is basically giving us those different services we've seen out there. So I, as a developer, I don't have to worry about where my Snowflake access is coming from, where my data product is coming from. So if you maybe just quickly go down here, I can simply reference it via the infra profile and then just reference my Databricks service. This is helping us to have that division of labor in between like the central platform team. They are in charge of provisioning a Databricks service, and us as a data product developer, in this case, developing our data product. As we've seen, there's three inputs. They are all data product inputs. And the maybe one thing I'd love to highlight here is our different expectations, where we can have different so-called consequences. The default consequence is failure. So, for example, here, if our model wouldn't check out, there are different fields or missing fields, we actually would fail, meaning we wouldn't consume this input. On the other hand, we might have certain conditions where we just want to issue a warning. So, for example, here, the data freshness, if it's not available weekly, we still want to continue processing that data and making it available, but we want to issue a warning and inform the team observing and maintaining that data product. Then specifying our transform here, again, we are just referencing our Databricks service. We could fairly easily switch that over in between DuckDB implementation over to our Databricks implementation here. And furthermore, what we talked about earlier, we have our trigger conditions here. So this is basically specifying when we should run, when we should trigger this transform, balancing not too often, but also in a timely fashion. Great. Then we come to the outputs. very simple. We say which promises we are having. We can define the different ports on which we want to make it available. So as we've seen, Snowflake, ADLS, and Pinecone should be available out there. And this means our different models, semantic models, in this case, we make them available for all three output ports at the same time. Now we come to the interesting part of how do we make API outputs available, or in this case, how do we make MCPs available? I, as a data product developer, I know that this data product is really good at answering get total quantity sold by sales channel. So I want to create an API call in an MCP resource for making this available. I can specify that in a fairly generic way, and then we use our driver concept again to make it available via MCP in this case. So in this case, we want to make it available. We call it for MCPs. This is a name you can choose, and we are using our Kubernetes Python MCP service to make that available. Last but not least, and this is also going into the field of safety, we can say who should be able to access, who should be able to discover our data product here. So we distinguish between two levels at this point in time, and this is first of all metadata access or data product access. Who can go in and see the metadata about this data product? Second kind of control we can issue is the actual data access. So who can get automatic API-based access through the data product itself? And that can be either the same or could also be a different group out there. So in this case, all employees can actually see the data product and discover it, but access to the underlying data is only granted to the sales team, marketing team, and our CFO, Brian, out here. The nice thing about those controls, they're applied throughout all output ports. So I don't have to do something special in another system for my MCP servers, for my MCP tools, for my MCP resources. It is all handled within one framework of access. With that, let's actually quickly check how we can leverage and how we can apply our specific progressive tool discovery out there. As mentioned, multi-channel sales, we are offering access to sales data, and we want to see like get total quantity sold by channel. So this is accessible to any agent system, or in this case, I'm going to use Cloud Code, which I configured to access the cluster endpoint or the MCP gateway to our cluster. So here, wait, I prepared that question up front, so I don't want to type it live to not mess up. But basically, what we want to know is what is the total quantity sold in stores? So we're asking for one specific channel out here, and we want to go through that pattern of progressive tool discovery. So the first thing we say, like, please retrieve available MCP tools and resources from Nextdata OS first. So let's run this, and it's with all live demos. Let's hope that our demo gods are nice to us today. They seem to be nice. And the first thing we're seeing here is that the first call is our discover call, as we said. And that's going to be like, we see like what tools are being available for that specific request. And here we get like our multi-channel sales get total quantity sold per channel. This is the new tool we now have available. And now I can see that there is this new tool available on this channel, and we're going to use it to answer our question. And the total quantity sold in stores is 8 units being out here. Great. And we would ask another question. We might find another data product. We might find other MCP tools being available for other questions. So we are not overloading Claude in this case with too many tools it then has to choose from. With that, let us jump back to the slides. And just to kind of like wrap up, so what we see as a scalable data infrastructure road to go from like this prototyping world to a really production value creation world for Gen AI are kind of those four pillars: standardization, where data products serve as a standard interface; speed, where data products enable us to match the autonomous agent speed, both in terms of like developing new agents, supporting new agent technologies, and also thanks to Nextd, develop new data products, so making new existing data sources available to potentially exist to systems existing up there on top. Next layer would be specificity. So as mentioned, our domain-centric Gen AI, context-specific data and tools based on your task at hand. And last but not least, safety, where policy enforcement across data products is actually enabling us to still have the control while enabling our distributed data product developers developing data products as quickly to match up the autonomous agent speed we mentioned here in this pillar. With that, first of all, thanks so much for listening. If you're interested in more, we got more resources on our website, nextdata.com. But otherwise, I believe, Shab, we have some time left for questions.
Yes, we do. We have a couple minutes left for questions. Feel free to drop them in the chat or in the Q&A portion. Me. One question that we did get from someone who couldn't attend, what's the difference between putting an MCP server in front of Snowflake versus building data products with MCP by default?
Yeah. Let me see whether I can go back in the slide deck. Uh, I think it comes down to the pillar here. We had here specificity. If I'm making too much data available, and the same is true whether I'm putting like an MCP server, exposing my entire data lake, my entire Snowflake, or the same is true if I'm going through RAG. If I'm making too much data available, which might not be specific and like useful to answer a particular task or question, I first of all, I'm going to pay more money because I'm increasing the tokens being leveraged to answer that question. And secondly, I'm going to get worse results, as we saw in the LangChain benchmark out there. The task-specific performance is decreasing if I'm giving too much context to the LLM, to the agent.
Awesome, thank you. And let's see. Uh, Another question that we have. If I already have data products defined in my catalog, why isn't that enough for agent-based workloads or multimodal access?
Very, very good question. So, um, it comes down to the discovery aspect. So we are mostly here in this, but let me maybe jump over to our cycle here without having to rebuild the entire slide. With the catalog, its catalog is a static asset. So with a static asset, I can see all of this is available, but I can't make it very specific to my task because I could do, but I would have to build a system which is grabbing like all the metadata and make it accessible. So the interesting part we didn't dive into too much is if we are adding an agent accessible tool, the nice thing, if we do that dynamically with progressive tool discovery as we do here, I can actually make the description of that tool, of that resource specific to the request. Imagine, for example, a request coming in. I need the latest data, which needs to have been updated in the last 7 days for this report to make sense. So only give me tools data which has been updated in the last 7 days. With that additional context we have for that task, we can enhance the description of that tool, of that resource with that information, basically passing that on to the LLM through the MCP tool description. And I think this is kind of like a big difference where we are moving from the static world to a dynamic world where this is created on the fly, specific to a particular task. And it's also different than if you're just to that earlier question, if you just bring up your own MCP server, you're going to have a static description of what data is available. Because in this case, we do that dynamically and progressively. We can actually enhance the description to your particular task and hence make LLM performance faster and cheaper.
Thank you, Jörg. One other question we got from Dinesh. Can data products interface with data which is being hosted inside applications running as Kubernetes pods?
Yeah. Um, I mean, first of all, I think as of right now, many of those storage systems here, they're actually going to run on a Kubernetes pod. We mentioned DuckDB as one example. This is something we see fairly often, where kind of in a prototyping environment, often DuckDB is being used to prototype like a new tool, and often that's going to run in a Kubernetes pod. I think this is one class which still falls in kind of the managed category of data. The other part, if we're talking Kubernetes pods or Kubernetes APIs, is kind of more like unmanaged data where I just have some APIs available. Again, this is something which I can make accessible to LLMs by building if you want to call it like an API aligned data product, making that unmanaged data accessible to your agents, to your LLM. And therefore, it doesn't matter in the end where it's running, as long as I have an API endpoint I can access it from.
Thank you. And for the sake of time, we'll take just one more. So, from per team, how would you create new and novel data products, particularly composite data products, where different data products autonomously or through prompting interact with each other?
Um, I mean, the usual interaction of data products, let me just see which slide is probably best, would be this one here, right? So if I understand your scenario correctly, you would be in a world where you have customer feedback, a data product where you collect all this like unstructured, scanned documents people filled out in a store. And then on the other hand, you got your structured Amazon reviews out there, which might just be a snowflake instance. And now you want to aggregate across that with your customer feedback data product. So the pattern we are often seeing is using GenAI to create this data product. So this is what we call Nextdata. I think, Shab, we actually will have another webinar blog post about this. So if you're interested in how that works, to be seen later, or follow our
Coming
website,
soon.
basically. Yeah, yeah. But basically, I would create that data product, and then that data product is consuming from these. And whenever they are updated, we saw the center and trigger policies when we looked at the Python spec earlier. And then basically, I can say like, hey, if both of them are updated, uh, let us update our own output. Let us run our transform. And so this is where I can sense changes from upstream data products and then update my downstream consumers.
Wonderful. I think, yeah, we're at time. We do have a couple more questions. I'm happy to send follow-up answers to everyone after the call. And I will be sending out a brief survey as well as a set of the slides that Jörg showed. But yeah, thank you everyone so much for coming out, for all the questions. We'll be hosting another webinar very soon next week around safe data for AI. But yeah, thank you again and hope to see you all very soon.
Thanks a lot.